by the InnovaWorld Research Center from InnovaWorld Private Limited from November 4th to November 9th, 2024. This program marks a significant step towards equipping professionals and enthusiasts with the advanced tools needed to transform industries, solve complex challenges, and push the boundaries of innovation. As India's first private research center registered under MSME and established in Hooghly districts of West Bengal, InnovaWorld Private Limited has always aimed to be a pioneer in education and research. Our journey begins with a YouTube channel inspired by the visionary Dr. APJ Abdul Kalam and, and has since evolved into multidisciplinary research hub that focus on STEM, especially in the aerospace and aviation sector. Today, we continue to uphold that vision by expanding into emerging fields like artificial intelligence and machine learning, integrating them into sectors where they can create the most impact. I welcome Aishwarya Dhara, founder of InnovaWorlds Private Limited, also the founder and CEO of Skyfire Tech, co-founder and director of TEMS Tech Solutions, and department coordinator, Department of Aerospace Engineering, GNA University. I welcome our Chief Technology Officer, Engineer PK Dhara, former Assistant Scientist, VECC, in the Department of Atomic Energy, DAE. I welcome our today's guest, Professor Chandan Chakraborty, currently a professor in the Department of Computer Science and Engineering at National Institute of Technical Teachers, Training and Research, Kolkata, West Bengal, India. His academic background includes graduation in statistics honors from Ramakrishna Mission College under the University of Calcutta, Masters Applied Statistics and Informatics from IIT Bombay, and PhD from IIT Kharagpur. He is actively involved in conducting short-term training, faculty development, and national mentorship, etc. programs majorly in emerging areas like AI, ML, DL, data science, IoT, etc. Aligned with NEP 2020 towards quality improvement in technical education, on the other side, he is strongly engaged in the interdisciplinary research activities related to artificial intelligence, machine learning, deep learning, and generative AI algorithms for solving engineering problems in the area of healthcare and education. He has various publications in peer-reviewed journals in IEEE, Nature, Elsewhere, Springer, Wheelie, etc. Most significant research works including computational medical imaging using machine and deep learning models for cancer diagnosis. His credentials also include 105 journal papers, two US and two Indian patents, along with many national and international conferences, book chapter, etc. He received prestigious Young Scientist Award from His Excellency by Dr. APJ Abdul Kalam, President of India, by Indian Science Congress. He was awarded by Young Researcher Award from Department of Atomic Energy, DAE, and Fast Track Young Scientist by DST, Government of India. Professor Chakraborty was also selected for biomedical fellowship by ICMR Government of India for his contribution in biomedical energy engineering. Once again, I welcome each and every one of you. Let's make today's session one to remember. Over to you, sir.
Okay, thank you. Thank you very much for your introduction. And before start, I'd like to know the participants are in the other side, or how many participants are there here?
Sir, they're watching you on live, sir.
Okay. Also, okay, fine.
Yes, sir.
That's what I'm confused. Anyway, so good morning to all of you. First of all, let me thank the organizer and the Innova, the foundation, okay, who is conducting this Innova World Foundation, who is conducting this very important, skill development program on artificial intelligence and machine learning in industrial engineering, okay, being organized by Innova World Research Center, Innova World Private Limited, West Bengal. So I find the governing people, those who are present, like Mrs. Aishwarya Dhara, Mr. Pulak Dhara, Mr. Sudeep, and Mr. Bhuvaneshwar. I think they are the key pillars of this foundations, I believe. and the participants, majorly those who are watching today live this program. So because of the transmission, problem in the network, I will switch off my video once I start the technical thing. Okay, if anybody has any questions, I think you can note down. I will answer after my delivery. Okay.
Sure, sir.
So let me start my technical part by sharing the PPT, and just to confirm from your end whether this PPT is visible to you or not.
Yes, sir. It's visible, sir.
Okay. So today's topic of discussion on supervised machine learning with applications. So it starts with the terminology called artificial intelligence. Artificial intelligence has become very, very important in today's time, because it is not where the only growth is happening, or revenues are being generated by the companies and all, but the artificial intelligence has become a nation building tool. As all of us know, we have our new education policy 2020, where it is categorically mentioned about the artificial intelligence, machine learning. In one bracket, all the emerging technologies. Okay, all are mentioned, and it's not just because of mentioning it is mentioned. It is for implementation. So the new educational policy will adapt the emerging technologies in terms of its innovations, so that we can accelerate our education in a diverse domains, towards interdisciplinary domains, and it can provide the flexible learning environment for the learners, because it's from the educational perspectives. Now in the research front, the giant companies, they are in fact almost all the companies, from the big companies to the startup companies, they are performing extremely well and doing a lot of works and developing a lot of products, software products, embedded systems and all, which are performing the task what probably earlier human only used to perform. So coming back to this, that's why the artificial intelligence is very important to all of us. Now, by definition, what do you mean by artificial intelligence? Before that, I will start with the term called intelligence. So, what is intelligence? Intelligence basically refers to an ability to solve a complex problem, right? That is the meaning. That is the inner meaning of the intelligence. Now, we are the human people in this planet as a living entity having human intelligence. That means the human's ability to solve a complex problem. Okay, initially for the intelligence it was ability to solve a problem. Now human intelligence, that means human's ability to solve the complex problems. We are the human. Given any complex problem, we think, do research, and then finally come to the solutions. No other living entity in this world can solve a complex problem, right? They, based on their nature, behavior, they perform the task as per their understanding. That's what humans are referred as a supercomputer. Humans brain are referred to the supercomputer. So started with the term called intelligence, then came to the step called human intelligence. Now switching over to the artificial intelligence, where it is understood that whether a machine can perform a task what a human used to perform. That means it's an ability of a machine to solve a complex problem. So humans ability, now machines ability. So machines should have ability, or whether machines have such ability which will um, provide a solution in terms of solving a complex problem. That's how artificial intelligence is, right? Now how machine will solve, that's what the whole gamut of algorithms in terms of machine learning algorithms, mostly more than 80 to 90% area of artificial intelligence are driven by machine learning algorithms, machine learning. scenario. If you look at the right side, a onion kind of structure, kind of a Venn diagram in the onion pattern, artificial intelligence is the bigger umbrella, and machine learning is a subset of the artificial intelligence. So it's basically a major branch of artificial intelligence that develops methods, techniques that will basically how it will solve. First, it has to learn from the data. The algorithms will learn from the data, and then after learning, the algorithms becomes intelligent like human intelligence, and so that for an unknown instance, it basically performs the task of prediction, and that's how the machine learning machine learning section performs the task. So it has twofold activities. First, it will learn from the reality. Okay, if I extend the call the data, it's reality. So it learns from the reality. Reality means from the reality, the real data. So it will learn from the real data, and after learning, it will be knowledgeable. With that knowledge, it will perform the prediction kind of tasks. Sometimes predictions, sometimes classifications. These are the different types of tasks mainly we need in real-time decision making scenario, because everywhere we are humans, we take decisions, right? At the end of the day, we take the decisions. The decision is nothing but the classification, whether I should move here or there, or yes or no, success, failure, and mostly binary. And in case of for multi-class, multiple steps of decision, like you are asked that whether you are what is the degree of severity of certain disease. First, yes or no. If yes, what is the degree of severity? In case of, if you look at any biomedical problem, like a person is suffering from suppose cancer, then if it is detected, then immediately the second diagnosis has to take place, whether the person's risk is low or moderate risk or high risk. So different levels of stratifications, classifications to be needed. Machine, the oncologist or cancer specialist used to perform that task. If you can train a machine in the algorithm in a proper way, so that it becomes intelligence, so that with an expectation that it can perform the task in a the way the human expert used to perform. Anyway, will details again I will be re-explaining wherever required. Now, inside of machine learning, you find the deep learning. Deep learning, basically advanced machine learning techniques, where no human intervention is needed. That means no human will intervene. But in case of machine learning, called classical machine learnings, there human intervention is required. So I will majorly focus on as supervised machine learning, but some glimpses on deep learning I will give, and some real research works conducted in the biomedical areas, in the area of cancer detections. Maybe I will just briefly highlight, so that you will have certain impressions about that, and if you are motivated, encouraged from this lecture, I believe that it will help you in your future for planning in terms of higher education or higher research. Then it may help. That is my expectation. So in the training, what happens in the training, in the context of machine learning, training an algorithm is nothing but estimation of the model parameters. See, algorithm is basically, mathematically speaking, algorithm equals to logic plus mathematics statistics together. So logic plus mathematics statistics. So by definition, algorithm means a sequential steps, okay, needed to solve a problem, where without mathematics very difficult you cannot do, and you have to have a logic. That's what sequential, and all the computational things should come from the mathematics and statistics togetherly. Now the data, in case of supervised machine learning, we need labeled data. Since I mentioned supervised machine learning, then question naturally comes. That means there are some techniques which will be categorized in the class of unsupervised machine learning, of course. And another machine learning is called reinforcement machine learning. So today's discussion only on the supervised machine learning, right? So the first main, key point behind the supervised machine learning, you must have the labeled data set. What do you mean by labeled data? Labeled data means in a system, once you have a input informations, you will have the output. If you have a cause, then you have an effect. Like during Corona time, the doctors used to, diagnosis the Corona patients, whether the patients visiting the OPD at the COVID hospital, after investigating various symptoms, the doctor will tell, yes, you are affected by the COVID. It's symptoms, blood test, so many parameters, whatever, as many as parameters required for the investigation, okay, to reach to the decision. So you have a number of symptoms or blood parameters as a, you will consider as a input vector of variables, every variable indicating each of the parameters in whether it's a symptom or the blood test, RT-PCR value, or X-ray, whatever different parameters will come with various sources to come to the conclusion, more robust decisions. The doctor, with confirming 99% confidence, there the person has been affected by the COVID. So if you visit now any hospital, COVID hospital, and ask, sir, I would like to do some research on development of some machine learning algorithm for this kind of epidemic prediction model. COVID will come or not, we do not know. It is over. So what is the point of developing COVID prediction only? Let us go for epidemic prediction model. Now, under that umbrella, let's take a case study called COVID. Because you can only have the data COVID. See, in the machine learning and all, without real data, you will not get a real answer. To get the real answer, to execute the any kind of policy planning, in the reality, you must have the real data. Okay, getting real data is really difficult. Sometimes we generate the data. If you generate the data from from experiments or some field survey, that is called the primary data. And if the data are already stored or collected by somebody, Mr. X, and you are using that data called secondary data. But whatever primary or secondary data, if you in your machine learning computational lab, once you are bringing that data, and you have to cross check whether it's a label data or not. So if you visit now a COVID hospital and tell, sir, I would like to do this kind of research, can you please help us? Because medical data is a confidential data. Wherever confidentiality has to be maintained, you have to maintain. There are some protocols, ethical guidelines, and all. Maintaining everything, what you need, suppose a Excel file you are designing, where the columns are each of the parameters, and last column, the disease detected, whether patient wise it was a COVID patient or not COVID patient, and you are giving, that is the Y output variable, and X1 to X10, suppose 10 parameters, the input symptoms variables. So a number of input variables required for a human doctor to come to the conclusion whether the person is affected by the COVID or not. Now, if you visit now, because COVID is over, already COVID hospitals, they have in the register, they have the good amount of data. So you go and randomly take 1,000 data. Out of that, suppose you find 600 data which are labeled as COVID as per the doctor's recommendation, and 400 were found, they were finally detected not COVID. Maybe some symptoms were there, but all symptoms doesn't mean that always it will be COVID. There is some special things are there, because you are considering not a single symptom, you are considering so many symptoms. So some of the symptoms may be present, sometimes symptoms are not there, but still disease is present, which is called asymptotic situations. So all these different things may happen in reality, and that's what you need intelligent algorithms to perform the task in an intelligent way. It's not just a straight line, you give the input and get all of the output. Your output may be multi-valued, right? Your input is single valued, but output can be multi-valued. So here, okay, so I have to go quite fast. I'm explaining the concept. I think if it is clear to everybody, it's very fine, but I try to hit.
No issues. No issues.
Okay, so I try to hit up the fundamental things which will accelerate the next journey, and that's how I used to follow in my teaching and training process. So what do we see over here? The label data, that is the called label data. So out of 1,600 you have got COVID data and 400 healthy data, which are confirmed by the doctor. So that means an expert has already confirmed, and that's what it is called supervised. So you must have a supervisor to label the data before starting any kind of computational activities. So that data is called level data. In reality, you may ask, sir, every time shall we get a supervisor? No. So there are different situations where supervisors, experts are not at all available. Then your decisions are not known in advance. So that data called unlabeled data. So the way in case of level data, we have supervised machine learning algorithms to tackle the problem of prediction and classification. Similarly, in the context of unsupervised unlabeled data, unsupervised machine learning algorithms, typically clustering algorithms, are being used to handle the situation for grouping, and that is driven by pattern based, similarity based matching kind of criteria is fit, so that the heterogeneous data will be splitted into a number of clusters, where every cluster will have more or less homogeneous informations, and between the clusters will, because heterogeneity is minimized in terms of subgrouping the similar type of objects, okay, in the respective clusters. So that part will not be covered at all over here. So I will, even in the supervised algorithms, so many algorithms are there. Typical, those are very frequently used in our day-to-day research, and still publications still are being happening using those techniques. I will highlight, okay, as much as possible. So supervised machine learning data, like learning with the level data, some examples are given. I have given the biomedical example because some of the research works I have done in my research journey on cancer and blood parameter, malaria disease detection, and so on, MRI, CT, so many radiology, pathological image based diagnostics. Anyway, so here email classifications, all of us we use email. In the email, once you open Gmail, you find out in the left panel you have inbox, spam. So some of the emails sometimes are automatically redirected to the spam. But how it's happening? I think you can immediately backtrack. Definitely in the server, the email server, there is some kind of filtering, some kind of intelligent algorithms are there, which basically any input email, unknown email is coming to the server, is received by the server. The intelligent algorithm will perform a task for classification. So that intelligent algorithm will ensure that based on a number of keywords which are probably not being frequently used, some of the criteria definitely will be there. So criteria means number of parameters. So based on a number of parameters, it will be classified, it will be redirected to, or it will be sent to the spam folder. When some mails come, and it is very much helpful for us, the user, because any email, if we check in the spam folder, then that time we take caution. Okay, we become more careful than the inbox mail, because server, it's not the 100% correct always. Some of the important mails also are being sent. That's why always it is recommended that you play in the spam folder, you check before just blindly. So that is very important. Email classification in one example. Before that, the algorithm will be trained that which particular type of informations are being present in the spam email, which email should be classified as spam or main email. That kind of keywords definitely are as a dictionary are are trained to the model, because without, if you do not train the model the which one is what, then how it will perform the task, because machine is a without any cognitive sense, no human sensor is there, which is called cognitive factors, nothing is there. So it will perform based on the approximation, because machine learning area is driven by the optimization techniques. Optimization means you are approximating it's a functional approximation. You have a function in the model. In the model, basically you have a variable and the parameter fx theta. X is basically the input variable, theta is unknown. So given the value of x, the function still becomes unknown, still remains unknown, as long as the unknown parameter theta, right? Like y equal to x plus by plus c. If I tell x and y values are given, still a, b, c are unknown. So model is unknown, right? You can have a equation of a straight line, you can change the gradient, and you have infinite number of straight lines. If you fix the gradient, that means if you estimate the value of the gradient value, that is the model parameter. but how this estimation will take place, that then you will get the unique solution. So how that weight will be estimated? That weight will be estimated by functional approximation, taking the input output in the same context, and that way the network, basically the model, will see that ultimate output should not deviate from the true output. So we will compute the error at the end, the actual output and the machine predicted output. So the difference between the actual output and machine predicted output uh, will be referred as the error. So we will compute, total amount of error present in our approximation process, and then we will do compute the mean square error, and we will apply for different types of models, different types of estimation algorithms, called like least square estimation method for linear models, the maximum likelihood estimation methods for the nonlinear models. And after using those standard machine learning estimation methods, we reach to the approximate weight values, and iteratively it will keep on. So weights will be updated based on the new data, and as long as it will not converge to a particular threshold. So that way weights are become more. Otherwise, in one iteration, everything error will be very high. But after so many iterations, it will converge, and then you will stop at the optimal value wherever the decision maker is satisfied. That's how the whole scenario in the back end happens, right? So anyway, this slide talks about classification, supervised, unsupervised reinforcement. I think unsupervised, as I told you, it will discover the patterns from the unlabeled data. Reinforcement learning, it's basically learns from the agent, feedback. So here it's interactively it will happen. And just an example, like if you have the small pet in your house, you are bringing. So in the very first stage, the trainer, when they train, they give one comment. If that pet performs that comment properly, then you reward. Suppose one biscuit is given, but if it does not perform the task, but that is the feedback. So his response or its response is a feedback. If the feedback is proper, you reward. If the feedback is not proper, don't reward. If you keep on continuing these practice sessions, maybe after suitable amount of time, then if you just perform the command without giving the biscuit, it will start performing the task in the right way. That's what the trainer gives the training to the pets, and that's how they learn. So their learning process takes place based on the interactions. It's a feedback and reward kind of transition takes place. In the context of the supervised machine learning, you have various algorithms. Those are categorized like numerical classifier functions, where we deal with the techniques called support vector machines, neural networks, then regression models, whether logistic regression models. Okay, these type of numerical classifier functions are being used. So other way around, very typical conventional supervised algorithm classification algorithms. Out of them, few can be named, like Bayesian classification, which is probabilistic classification, but it is a supervised machine learning algorithm. Another algorithm called support vector machine. It is also statistical algorithm, and it's adaptive in nature, and it's very powerful algorithm because it can deal with the linear data and non-linear data more efficiently. Other than this, you have so many other things just by naming, like Gaussian mixture model, Gaussian discriminant analysis, hidden Markov models, and we quite simpler algorithm called k-nearest neighborhood algorithms, which are mostly non-parametric, where instance-based functions we use to use kernel density estimation, local regressions, and so on. Symbolic functions, like you would like to classify different numbers, okay, different alphabets, symbols. Then you can apply decision tree, classification, and regression tree. It's basically kind of a splitting the regions. Decision tree, it's a tree-like structure based on the certain criteria, which also selection of the criteria is an important factor over here. Accordingly, the classes, the objects symbols will be classified. And we have the aggregation model called ensembling learning, bagging, boosting, random forest. Very popular algorithms are there, but maybe one or two I'll be able to discuss as per the time constraint. These are the name of the unsupervised algorithms, so I'm not going to hit upon much on that. Now, to start with, one of the simplest supervised algorithm called nearest neighbor classifier. If you look at the graph below, before going to the definition above, so you have a two class data set, class 1 and class 2. Now, I have an unknown data set like that is called test example, that is the test data. So you have initially two class. Suppose the green one tells the healthy data and the red ones are called the COVID data. Now one unknown patient enters, then no doctor is there, then a computer is there. So based on the parameters, it should be classified. Now it's a non-parametric approach. So in this interface, like a scatter diagram, if I take this state example, looking at the whole data, whole data sets where class 1 and class 2 are labeled, it's a labeled data set. But this is unknown. So in which class, whether this test example to be classified in class 1 or class 2, that a task has to perform. Here the algorithm what we are considering nearest neighbor classifier. So nearest neighbor, these two terms are very common terms. Neighbor means your neighbor, you're the closest person sitting around you. That way, distance wise neighbor. Nearest, the closest most one. Now we will find out here no other parameter needs, whether mean, variance, other kind of statistical or mathematical parameters we are not using. Just we are using their spatial distance between two objects. Now this the which one is the closest most? This arrow shows that this labeled data, labeled blue pattern from the class 1 is the closest most. Rest are they are around this data, but their distance is quite far in comparison with this one. So that means it is a nearest neighbor to this unknown sample. So in a one nearest neighbor, if you only one, if you consider that is the most nearest one, so this is the most nearest. So I will classify this test example to the class 1, not class 2, because only one neighborhood I have considered. Then it is in short written as 1 NN. You must have seen K NN. That K, if you take 1, this is the 1 neighborhood. If you take 2 NN, 2 nearest neighbor, that means you compute, you look at the closest most 2 such patterns. So maybe this one is the closest most, U2, and in that case you find the 2 are from the both. So in democracy, the way the political party wins, when the number of they have to score the more than others. Here also same thing. In these two, you find how many blue balls, how many red balls, red colored objects. So 2 blue objects and no red objects in the closest most the criteria. So again, this test example will be classified in the class 1. If you take 3 NN, 3 class 3, then it might so happen these 3 will come into the picture still, because that unknown pattern, it is closest wherever closest most. So unknown will be labeled as that corresponding to that particular class, because your task is to perform that unknown object will be classified in class 1 or class 2. That is the task, that is the goal. And this algorithm, based on this algorithm using 1 NN, we find it belongs to the class 1, so it's a class 1 object. If you take 2 NN in the blue one, in the 3 NN still blue one, if you assume some red, some red color balls here also, the test is term is written na, so here somewhere it is given. Now if you take, then it might so happen the distance from this one to this one is exactly with the distance to this one, and that time it will take 4 NN. Out of 4, 4 NN, the nearest neighbors are identified. Then we will find out of 4 how many from class 1, how many for class 2. If I find from the class 1 number of objects are more from the class 1, it will be classified in class 1. If there is a tie, then again you increase. So why you will go to 1 to 2, 2 to 3, 3 to 4, 4 to 5, 6. This value will be increasing depending upon to break the tie and to have a more consistent or a robust decision. That is the key concept behind the nearest neighbor classifier. Now, if we apply in case of, in the broader case like image, because image is nothing but a digital image is nothing but a matrix. in the if you look at the matrix, in the matrix you have a rows, columns, that is the every in on a cell has its location and its value. In case of image also same thing. If you look at every location, there are suppose 4 rows, 4 columns, and every value basically is the intensity value. All of us know the range of the intensity value in case of grayscale or colors image, RGB's color scale, 0 to 255. So you can quantify the image, whether it's a grayscale image, that is 1 channel. If you have a color image, that's a 3 channels image. So you can have the cells with the corresponding intensity value. So it is done by the sampling. So test image minus training image, okay, and we get the pixel wise absolute value. So every cell in case of image is called the pixel. Try to find out how the training test image is how it is closest most to another image, right? There are two same type of images you taking, and you want to find out their closest closeness. You take the initial difference in absolute value, that is done by yellow and non called Manhattan distances. Now nearest neighbor, as I told you, if you generalize to k nearest neighbor, if you search in the Google, you will find out a lot of examples with that. Just a concept what I have already discussed, because thereby the data set were well separated, so it's very easy. But here data sets are quite complex because some overlapping things are happening. So here red objects are labeled objects class 1, and green objects are the class 2 labeled objects. But plus 2 plus signals symbols you find out in the black color, those class basically the unknown one. I want to classify this unknown instance to be classified either in class 1 and class 2. That is the task. So how to go ahead? If you consider suppose 3 nearest neighbor, so with respect to the every plus, compute their nearest 3 points. And if you once you find the nearest 3 points based on the distance values, then you find out of those 3 nearest neighbor, how many are from class 1, how many from the class 2. So here we find in case of both cases, 2 out of 3 labeled data set, combination of the red and green, 2 data points are from the class 1. So hence the this plus unknown instance basically belongs to the green class. And here also you find because distance wise this circling is done, okay. If you find data set some here the distance you are circled within, here concern is not the diameter, it's a concern about the closest 3 most closest data set around that unknown instance I will consider, and out of those 3 known instances, how many are from class 1, how many from the class 2, if 3 dimension, then how many from the class 3, and you just like a voting model, and wherever it's maximum, that particular instant unseen instance will be classified in that particular group. And that's how the whole nearest neighbor classifier, not much complexities are involved in terms of computing the any kind of estimation and all. Only you have to compute the Euclidean distance, spatial distance, using the distance measure. Now coming to the linear classifier category. Earlier it was a non-parametric one. Here basically we want to two classes of data are given: COVID versus health, right? Or climate condition you can take, cloudy day and sunny day, and you have a 2 parameters, humidity and temperature. If you get the data from any weather forecasting divisions, okay, the meteorological department, regional wise, so you'll get the regional data, and based on the minimum 2 parameters, temperature and humidity, based on that the nature of the day, and that way last 5 years data if you collect, you will have the huge data. Now if you simply plot in the XY plane, whether x-axis indicates temperature, y-axis indicates humidity, and you can have some overlapping but 2 kind of data sets. So based on the nature of the data, if you first attempt will be to classify, to separate these 2 types of data, whether cloudy data or rainy day and sunny day, based on the humidity and temperature, then you have to have a separator line. You need to separate 2 class, you need a separator. A separator is nothing but, here we are assuming as a linear separator. Basically linear, it's an equation of the straight line. We are giving the name linear classifier. The classifier is nothing but a straight line that classifier, straight line, it is a linear in nature, a classifier because it's a linear function. It will classify two classes. That's what its name is, classifier. Nothing much big, complexities. It's simply a straight line. Referred as a linear classifier because this straight line is going to classify your data to separate that which one will belong to the rainy day and which one will belong to the sunny day, depending on the features. Features are parameters we are used to call in machine learning. The terminology is called feature, characteristics, parameter, attribute, whatever we call. Ultimately, it's a feature. So a linear function of f inputs x that separates the classes, okay, a w x plus b. Use pairs of outputs and labels to find the weights matrix w and the bias vector. In this function, see, xi's are known because the data are supplied to you. So your input and output are known. Only the model parameters are unknown, w and b. So this w refers as a weight matrix because you have a number of more than one variables, input variables, and b is the bias that will basically help in terms of converging the model, because from where you are starting, that is very important. If you are starting in the convergence, functional approximation, during the functional approximations, the convergence scenario you want to achieve, if you start journey from very long, then it will take a long time to journey, because a lot of real-time decision making situations you will not allow even more than a fraction of nanosecond. Immediately decision has to be taken. Like robotic surgery has come. When a patient in the operation table, that robot is performing the task as guided by the human doctor. Of course, human doctor will be there in the console, but the operations will be operated by the robots. Robots is nothing but the machine. Sensors are given. Real time, live imaging will be taking place. Live, investigations will be taking place, and immediately whether which section has to cut, which one is not, that doctor immediately takes decision on live, and that time patients on the OT, and that time you take 10 minutes to take the decision, then patient will die. So that is the very, very important wherever life risk factor is attached. So we cannot allow the approximation even for more than sometimes more than microseconds, right, nanoseconds, like that. So this parameter will be parameter learning. Parameter learning, basically estimation of weights, that will be done by solving a loss function. Loss function nothing but the error, entropy, and so, some criteria. So we use the perceptron algorithm is often used to find optimal parameters, by which we update the parameters until a minimal error is reached, because we will always error in any decision, in any decision making process. Accuracy will be high, error will be as minimum as possible. So if the decision will be more accurate when the amount of error is very, very minimal, and that's what we need it, like the gradient descent method, right? And linear classifier is basically a simple approach, but it's a building block of advanced classification algorithms like support vector machine and neural network. Okay, so in this slide, you look at the graph, right side scatter plot, a linear line, green line, that separates the two groups. Like you want to separate from the tiger's face to the cat's face, right? Some similarity we will get, but some dissimilarity also will come. So to identify the most distinctive features based on which we separate, the way our human eyes captures the informations, accordingly the image will capture the informations. Basically, we also see that image what is framed in our background retina, right? If you close your eyes, can we distinguish anything? No. Like the image is formed in the backend, our eyes are nothing but the camera. And if you use the smartphone camera to take the photograph, a kids also can differentiate of how it's happening, how human sensory organ is doing, and that's how the algorithm is there. That process will be reflected in the context of the neural network majorly. Okay. Coming to class H, whatever. Sorry. So let's we understand this cat image is the input image. After that, that is basically quantified. If you this analog image, if you digitize, it will be a matrix. Then one row after another row, if you make a column vector. So that is basically your input data. You have the weight matrix, proper selection of the weights of the matrix plus the bias W and B, which in the supervised learning we will be computing. But how these things happening? If these weights are known, bias are known, then an input unknown image which will be quantified in with respect to its intensity values. And if you the function was Wx plus B, so it is a W and this is X plus B. So you are going to get using matrix vector multiplication, maintaining their proper order. We will we will get basically this vector output vector, where suppose the negative value indicates any negative score indicates cat or higher positive dog, and in the middle it is a sheep score or like it. So basically it's a classification. If we fix a rule in the programming level that yes, that the score value less than 0, always that object will be classified as cat, and that way it will classify, right? Linearly separable techniques, linearly separable line like this, but your reality is not we should not think reality is simple. Reality is complex, nature is complex and uncertain. So once we are going to deal with the complex situations, then definitely we are going to face the complexity in terms of the non-linear data. That means the data which cannot be linearly separated, that will be separated by non-linear function. That's what the B graph you can see. The green, the blue class of elements, that class of blue elements are circumscribed by the green class of elements. So basically class 1 is the blue, refers to the blue blocks, and class 2 the green balls. But can you separate by a straight line? Of course not, you cannot do it. You need a circular boundary to segregate the two classes. Like here you need you in case of graph A, you can easily separate by a straight line, but here you cannot separate by a straight line. You have to have this kind of circular boundary to do that. If you forcefully do that, then that will be the your error will be very much high, so decision will be affected. So what to do in this case? In case of nonlinear classifications, there is one approach called kernel transformation, where in the raw data level you suppose consider two parameters, two features, based on which you found that they are nonlinear. Now you make a transformation called kernel transformation, so that the number of features will be increased. So that is called higher order feature space. So in the higher order, like in two-dimensional scenario, they are nonlinear. But in the five-dimensional, which is hypothetical because we cannot draw more than 3, even three-dimensional, they become quite. So in three-dimensional, you cannot separate by a straight line. You can separate by more than two-dimensional, like three-dimensional onwards. You have to separate by a plane, and that is called hyperplane. So a overlapping situations or a kind of a complex situations that can be separated in the higher order feature space. Okay, in imaginary mode you have to do that, but by a plane is required to segregate, and that is a complex situation, but that is dealt by Bayesian support vector machines situations. What I told over here, you can see. So in the two-dimensional space, the data are segregated by nonlinear function, that is a circular function. But after putting a phi like a kernel transformation, that means on the feature space, then here it was a two-dimensional interface. Here it has become three-dimensional. So in the three-dimensional, the reds are there in the one side and blues are in other side, so that a plane can separate. Okay. In two-dimensional, they were basically merged with one. In three-dimensional, their merging has been broken, and the middle wall kind of thing. So one wall between two rooms. That kind of situation, things you can imagine in your brain. Now we can face two-class problem. Usually, most of the decisions are driven by the binary classification approaches, where you are taking the decision like whether go or no go, success failure, profit loss, and that kind of. And in case of multi-class classifications, we are basically 3 classes we are considering. So here you can separate 2 classes by a straight line, but here they are straight line, but multiple such straight lines required to perform the classification task. It's not that one straight line cannot separate more than two classes. So you can draw more number of straight lines to separate more than two classes in this way. If it is, of course, if it is linearly separable, right? And this kind of situation is called multi-class classification, because decision making scenario, as I told you, to compute to understand the degree of severity, you're talking of, suppose, different gradation. So multiple gradations can be done: low, medium, high risk, class performance of the class, right? Like poor performance, moderate performance, excellent performance, and so on, like this. Another algorithm called Bayesian learning for prediction. So Bayesian learning, basically the concept is that using the past and present information, you can predict the future. That's what the human does. Anything you want to plan for tomorrow, your own experience and the current situations, that information you need. If you don't use that, that means heuristically you are doing there may be some question of validity and so on. But keeping aside that thing, if you use the past information, past record, past information, and present knowledge, integrating these two, I think you can have a better, robust, optimal prediction, because prediction should be also robust. Otherwise, if it is inconsistent, then there may be a loss, great loss, right? So Bayesian prediction basically has been originated from the concept of the technique called Bayes rule. So Sir Thomas Bayes in 1763 introduced the technique called Bayes rule using conditional probability. So you can remember, you can think of that more than 250 years back, one technique was discovered, and today in the machine learning we are going to discuss the same technique, how it is so important. Why? Because in the practical field it has a lot of applications, and it has solved a lot of problems efficiently and helped the human population for smooth in the related area, some smooth activity and so on, because nature is uncertain. So you cannot deterministically everything with 100% accuracy you cannot predict. So prediction also will be uncertain. That uncertainty is driven by the randomness. The randomness is driven by the probability theory. So this rule is driven by the probabilistic concept. So whatever the prediction we will get, that will be touched up, that prediction will be based on the probability in the range of 0 1. Like 90% chance, what is the chance that after surgery a patient will survive? Say patient survive or not, that is 1 and 0. But a patient party asking to a surgeon, sir, can you tell me after this surgery what is the chance of his survival? So doctor says that 95% chance survival, you will be happy. If there's no, it's 50-50 or 30%, 40% chance. So your success rate is low than failure. Then you will rethink, you will cross verify, you are in dilemma. Then you will do a lot of things. Okay, before coming to the whether I will be giving permission for operation or not. That's how the things are in reality happens. Now all these happening things can be we are trying to model from the machine learning aspect, whether it's a deterministic model or probabilistic model. So the situations wherever uncertainty is the very important factor to take care, then probabilistic classification like Bayesian classifications helps a lot. As told in this slide, that the relation in many applications, the association between feature set and class is non-deterministic. So you need definitely some classifier which will deal that kind of uncertainty, and that is possible only when you are going to deal with some probabilistic models, when you are going to solve any probabilistic problems, uncertain problems where the relation between the feature set and the decision, inputs and outputs, that relation is not deterministic. Then you need probabilistic models to quantify the situations and to predict probabilistically. Okay, so this is the concept behind the algorithm, and what you can see from here, it's a very simple formula based on the concept of the conditional probability. So probability of class given feature, that means a number of symptoms, given a number of symptoms, what doctor does? a COVID doctor. The patient enters in his room. He asks about some parameters, symptoms. They react based on the parameters. Doctor tells, yes, you have the disease, okay, or not. That is the class. Class is the disease present or not. Feature is the number of symptoms. So a computer, how can do it? So computer, it's a conditional probability that given a number of parameters, okay, investigated for a unknown patient by a non-doctor, a paramedical person, whether and given that input to the machine can probabilistically predict whether that person has the disease. So what is the chance? Class equals to 1. What is the chance? Class equals to 1 means class 1 equals to COVID positive, class 2 equals to COVID negative. So it will compute the probability for every person's two probabilities: success means COVID positive probability, COVID negative probability. And based on where it is found that the COVID positive probability is more than the COVID negative probability, then of course that patient will be detected as COVID positive. So the way human used to do, a machine will definitely will predict with some probability, okay, 92% chance that this person has the COVID disease. But this will be done only when the equal, you can see the formula in the right hand side. So this can be obtained when you have the values in the numerator and denominator. So using the formula, we can write probability of class given feature equals to probability of feature given class multiplied by probability of class divided by probability of feature. So probability of feature given class means you have to have the level data, as I told you in the beginning of the lecture. That time you have to compute the likelihood value. Yes, you have 600 COVID data. So what is the pattern of the features for 600 known COVID data, which are labeled already? So machine will learn that for the COVID data, what is the pattern of the features, and for the non-COVID, that is healthy, those features, how they are altered. It will not be simple. Temperature profile will vary for the COVID positive group than the COVID negative group. So this pattern has to be trained to that model by means of using multivariate Gaussian distribution, and it's called likelihood function. So probability of feature given class, that data we will have, that data will compute from the collected data, obtained data from the hospital, multiplied by probability of class, that is the prior experience or prior information. Yes, in our population, what is the chance of having the COVID? So randomly during the COVID time, randomly 500 people are sampled and found, suppose 300 were found to be COVID positive. So our prior probability of the COVID positive will be 300 by 500, and prior probability of COVID negative will be 200 by 500. And that's how these probabilities are computed. Probability are estimated with respect to the proportion, because in reality directly probability you will not get. It's a mathematical formula, but you can estimate from the reality using the proportion factor. Next, this rule I told you, wherever maximum, if a person's probability of having the disease 80% and the probability of not having the disease 20%, then what you will do? Of course, he is the disease patient, immediately, suitable doctor will see. Always remember, machine will not give the final verdict. Machine will help the doctor to make the decision more efficiently, more accurately. And after screening, after getting computerized result, always it is written in the back, it is a computerized result. It has to be verified and validated by the expert doctor. So how it will affect the working environment, how it will help improve the working environment efficiency. Suppose earlier one doctor used to by compulsion in the rural hospitals, the doctor has to see 500 patients. Very difficult. It's an inhuman job. But if a machine comes, it will filter, it will screen. Out of 500, machine says that, yes, these 180 people are really having the risk more than 80. So those 180 will be given the first preference. It is good for not for the doctor. It is good for first. It is good for the patients. So out of 500, here no in the queue they are standing. People will take those who are. It's not that railway ticket reservation. Priority will be given who is having the high risk, and that has to be computed probabilistically. So you grade with respect to the degree of severity, not as per their arrival, right? And accordingly, they will be given to the doctor. So doctor also will be happy, because after, instead of 500, even only 200 look. He will look. mentally he will be relaxed and will be able to perform satisfaction, because we are human being, we are driven by our cognitive senses, and that we become bored, we become angry, all these our mood swings, everything happens because of our that, because we are the people, the humans, like other living entities, say electrobiomagnetic fields all are there in our body. Heart is our electromagnetic field. Okay, it radiates signals. Anyway, the rule I have told you, this is multivariate Gaussian distribution to generate the likelihood functions. So training the model means the model parameters will be estimated from the data using appropriate optimization technique in order to reach to the optimal values of the weights. So unknown weights will be estimated as known approximate value, because true value will never get, because error cannot be minimized to exactly 0. Okay. Why normal distributions? According to the statistical theory, in the context of central limit theorem, sample size more than 30, all the distributions, whether discrete and continuous, whether it's a discrete, continuous, and any other known unknown distributions can be approximated to standard normal distribution. So that means standard normal distribution basically is the father of all distributions. It can absorb everything. So if you do not, all data sets pattern cannot be modeled, because some other probabilistic distributions are there. So it's a context dependent. But some contexts where you cannot judge that which particular standard distributions can be applicable. Then you increase the sample size and approximate. There is this approximation rule by which you can convert into the Gaussian distributions, normal distributions, and then take the advantage of the distributions in order to model the likelihood function. Modeling likelihood function is learning the algorithm. Now, when many features are there, we will assume that features are independent. That way, it will reduce the complexity of the algorithm. And the most recommended approach is to assume the independence amongst the input variables, and then the joint density of the joint distribution of the functions under the assumption of the independence can be written as the product of their individual marginal distributions, and that way computational things becomes more similar. So here basically we are going to compute, that we will see through an example. It's 12:30. Okay, so what you can see, it's a air traffic data. I'm going to say an example. So it's our national map, where all the red points are marked as are basically the Indian airports. So we are going to get a data. Suppose we have we used to have a data regarding the arrival of flights in the routes. So all the green lines are nothing but the flight routes coming from different airports to Delhi airport. So from the Delhi ATC, Air Traffic Control Divisions, we suppose we have taken a data set about the arrival of flights in the routes from any airport to New Delhi under certain conditions. What are the conditions? The conditions are day, season, fog, and rain. Day, one attribute, like one feature; season, another attribute; fog, another feature. Like variable 1, 2, 3, 4, the input variables, right? And you have a decision variable, that is the class. Either flight landed on time, or flight landed lately, or very lately, or cancelled. Now going back to a table. So this here, as per the 4 such attributes and 20 such flights data have been randomly collected from the ATC, and every row in this table indicates one flight's information. Like if you describe the first row, it talks about that in any weekday, these are all past informations already recorded, pre-recorded. It's not the based on this previous data, I will train my model. The model will be trained with this previous data set, as you can see in the screen in the tabular form, After learning the algorithm, it will basically make certain predictions. So I'm describing, then I'm giving, I will raise the questions, and that will be the solution will be shown how probabilistically it is dealt with. So in the first row talks about the flight number 1 in any of the weekdays during spring season when there was no fog and when there was no rain. So flight landed. Similarly for the second flight, second row, third flight, third row, fourth flight, like this way. So in this way, there are days like weekday, holiday, Saturday, different types of days, season, spring, winter, summer. Okay, fog, whether fog is there, no, normal, high, rain. Every attribute will have different values, but it may be repetitive with respect to their each of the flights. So 20 such rows are there. Every row is nothing but a one flight's information. So now what is the question? Now, given this knowledge, piece of knowledge about the data and classes, can you find out that for this unseen instance, given this data, if I now ask about the future, like in in any of the weekday during winter season upcoming, when fog level is very high but there was no rain, so what is the maximum what is the best possible class we can expect, what is the best possible decision? So based on this input data, whether flight will be landed on time or lately or very lately or cancelled, can you give the answer? And with scientific justifications, you have to give the answer but with justifications. So then we are rearranging the data sets. As you see from that, Bayes rule formula, right side, we have to compute the likelihood value. Now from this stratigraphic data set, we are going to compute the likelihood value, prior probability, based on which we will compute the posterior probability, that is probability of disease given class given symptoms, features. So first we will rearrange the data with respect to by splitting the class into 4 levels: on time, flight landing on time. Class has 4 levels: on time, late, very late, and cancelled. And attributes also different days: weekdays, Saturday, Sunday, holiday. Spring season, spring, summer, autumn, winter. Similarly, fog, none, high, normal; rain, none, slight, heavy. Now out of 20, it is found that 14, how many landed on time? 14. 2 landed lately. 3 landed very lately, 1. So 14 plus 2 plus 3 plus 1, 20. Fine. Now out of 14, those who have landed on time, out of them, how many landed on a weekday? 9. So what is the probability? 9 by 12. That is 0.64. That means, what it means? It's a likelihood function. So what is the probability that a flight will be landing on a weekday, provided it has landed on time? So total, how many landed on time? 14. Out of 14, 9 landed on weekday, 2 landed on Saturday, 1 landed on Sunday, 2 landed on holiday. So 9 plus 2 plus 1 plus 2, that is 14. So that way you can compute the whole likelihood values. Now once likelihood values are computed, then I am going to compute the prior probability of class in this formula, if you remember. Then out of 20, 14 have landed on time. So prior probability for landing on time is 14 by 20. Out of 20, 2 landed on lately. So the prior probability for the late landing will be equals to 2 by 20, and so on. So for every class, you will have each prior probability. That means it's a 4 class means 4 prior probabilities, 2 class 2 prior probabilities. If you are going to deal with 10 class problem, 10 prior probabilities. Now given the prior probabilities and the likelihood values, I am going to compute for every class for this unknown flight informations as an input. I will compute for every class. This flight will be classified in class 1 or class 2 or class 3 or class 4. Accordingly, this value, as you can see in the numerator, it was a likelihood multiplied by the product. Since here prior probability was 0.70 for the landing on time class, so class equals to landing on time, the prior probability 0.70. Now the likelihood value for the weekday 0.64. You can see this is a 0.64. Similarly, 0.14 for the winter. For the 0.14 is the winter. For the fog, it is 0.29. For the heavy, is 0.04. 0.07. So if you multiply, you are getting this one. Similarly, you can compute for every class the possibility of classifying, the likelihood, likeliness of classification in that particular category. And if you find the way you apply that logic, if a person has 80% chance that it will be attack the disease, or 80% chance that patient has got the disease, so they will be recommended the disease. So here we will compute the out of 2 maximum you choose, here out of 4 you take the maximum value. So here it is found that 0.0222 is the maximum value. So that means your correct classification will be very late. So that means in future, if a flight is expected to land on the weekday during winter season, when the fog level is very high, dense fog is there, and it is raining heavily, then it is expected that it will land very late. It is expected, it's probabilistic. It is expected that it will land very late. These ways, so many such applications are there. Okay, so many such applications are there in the spam classification. Even a Gmail predict whether it's spam or not. That is the application Bayesian rule. Medical diagnosis, given a list of symptoms, predict whether a patient has got that particular disease or not. Whether forecasting climate change kind of situations based on temperature, humidity, predict it will rain tomorrow or not. So many more, your life is full of classification and predictions, frankly speaking. Every time you have to be judgmental. That means you have to take the decisions. Accordingly, things will be approved. You will be going up. I think I will stop over here, and with because time is also has crossed 12:30, and I hope whatever I am able to deliver to the audience, to some extent they will be geared up and having some whatever little amount of knowledge I have tried to deliver from my end. Thank you very much. Thank you all of you. If you have any questions, I can take few questions. Okay.
Yes, sir. Thank you so much, sir. And we have few of the questions. So first, many of them ask the most challenging question. There are certain, I think there are some researchers or professors are there. The major challenges that they're facing is that data availabilities.
Yes.
So sir, to work on those machine learning, especially in an industrial application, so
Yes.
how to get data and how do we validate the data this data is authenticated?
Yes, so that's what data validation is very important. See, data, as I told you, data. Once we plan any problem, design a problem means first we identify the number of parameters or features, right, and the class, the group. Now, if that situation is known, that means from hospital or somewhere, from some resource or telephone industry or some other, they will, because companies they don't disclose, they do a lot of survey based data to collect. Either it's a survey based data, or depending on the nature of the problem, or experimental data. Those who are working in the laboratory experiments, they are recording the data and putting the CSV file and Excel file. Now getting data is really a challenge, because given the data, machine learning activity starts. But before that, how to get the data? So it will depend upon, suppose somebody wants to, if you want to have the weather data, go to the weather forecasting department. You have to approach for developing different climate models. That is one hot area where all world leaders are talking about today, about the global warming and all. So climate related data you will get, and then sector wise. So if you, it's a challenging situation, the problem is fully known, no data is available, then you have to make a survey based, questionnaire based, or the field visit. All these things are required time to time. Can I just take you one phone call?
Okay, sir. Sure, sir.
Sorry. Yes. So, what is really challenge how to get the data to, when started my biomedical research, I used to visit the hospital, clinics, doctors, coroner, used to expert. I had to contact and discuss with them. So expert selection also really important, because in case of the area, expert will validate only at the end. Otherwise, what is there is no such now. If you go for data cleaning, outlier detection, noise data needs to be cleaned up. Then technically, through algorithm techniques are there. But which data to be labeled, that will be done by the human expert only in the concert. If somebody wants to collect the data on the agriculture, okay, in the agriculture disease classification problem, nowadays a lot of AI in agriculture things are happening. So people are going to the field and collecting the image data and asking the agricultural the botanist, plant scientist, that which particular disease has attacked to that leaf of certain kind of vegetables or rice, other kind of crops and vegetables. And they have to first identify. Otherwise, and if you think no supervisor is there, then you uh, go shift to the domain of unsupervised machine learning. You characterize and similarity based matching will give, but nomenclature cannot be given by the machines. Machine will tell, okay, out of 500 images, suppose 400 images are very similar, so they can be the particular type of it is attacked by certain depending the nature of the image data. It will be they are similar. That means similar type of infections are there. So that way can be done, but labeling will be done by the expert. So human expert is required at the beginning and at the end. But that data either will be getting labeled or unlabeled. But validation has to be done. Now technical validation, like a cross validation, that is once you have an enormous amount of data, whatever the error we are promoting, whatever the error we are telling, that must be validated using different cross validation methods are there. Okay, technically. But human validation at the end, whenever life risk threats are there, then doctor at the end doctor has to confirm. So depending on the field. Okay. Next.
Sir, we have one more question. I think he is working on some type of sound and spoken words. So, which type of algorithm will be used or will be better identifying the type of sounds or spoken words? So, can you insight some few things about it? Am I audible, sir?
Sorry, just had to take call. So
No problem.
speech recognition, speech signal.
Yes, sir.
What is the question?
Sir, I think he is asking the which type of algorithm will be suitable to for working or classifying the what prediction and speech recognition.
Speech recognition means he is going to work on some classifying signals. So
Hmm.
again, some kind of hidden Markov model is the kind of a model that is best, more or less suitable. Hidden Markov model.
Okay.
Hmm.
Sir, I have one question from my side.
Yes,
As you have shown one like air traffic management,
yes,
air traffic datas, right?
yes.
So, sir, if we have to work on those particular areas, like for an
Uh,
example, air traffic management, and it is a matter of a year that to get a data, like every day, each day,
uh,
the situations are different.
Yes.
So as you have said that landing time and takeoff
Yes.
time,
Mm.
whether they are landing on time or advance or not.
Yes.
So how can we get those data?
From
Because
ATC, you have to contact the Air Traffic Control Division. ATC is there, no?
okay, yes, sir.
So you have to apply, write the application to ATC, and they will reply back to you. If they do
Okay,
not have any kind of problem in disclosing or any kind of non-disclosure agreement, they can do that. But they have the full amount of data. Now, approaching them and understanding any limitations, anything, because for research purpose, if you tell people, sometimes don't have any problem. But it's a private companies, how they will take care, do that, I do not know. If it is run by the government, you have to see. I have taken as an in the case study, but in
okay.
reality, it's not the data from taken from any ATC.
Mhm.
So you just you have to contact and see what are their pros cons and what
All
they.
right. So actually, currently, some of our team were working on some of the open source available in their website,
Hmm.
in this iCow website. So, is it? Do you think that's good to work using this open source data, which is available, like quite
Open
authorized?
source is good. Initially, if you don't have something, don't have anything, then using open source, but at least some benchmark data, open source benchmark data, you can use for training the model and learning practice purpose.
All right.
But if you want to make certain decisions in reality and going to recommend some decisions in your
Mhm.
application things, that time the data needs to be, new data required depending on this. Initial for training, you can do that. Like in deep learning, there are a lot of pre-trained models. They are already trained with the
Right.
international benchmark data set. Now you
Yes.
want to apply in your application. So your application small data sets, even you have to feed, so that the initial trained model will be fine tuned
Hmm.
for developing for prediction purpose. There are different techniques called pre-trained models in the context of deep learning.
Yes. Yes, sir.
Uh, so that's all. Okay.
Yeah. Okay, sir. That's all the questions we had in this session. And sir, thank you for your valuable time. And we are truly honored to have you and expertise and giving enlightening on this supervised learning. And we got to learn so many things, that techniques. There are several new techniques that many of our interns or many of our professors that whoever has joined this session has enlightened, and many of them has appreciated about this technique called naive Bayes algorithm.
Uh,
So many of them were very new on this technique, and the way you have explained it, it's truly nice. They have appreciated on this particular approach, sir. So thank you once again, sir. And in future, we'd like to collaborate with you, sir, with some sort of events or, in fact, kind of research work, sir.
okay, thank you. I also enjoy with all of you virtually, and hope hope everybody is having some knowledge on this, and
Definitely, sir. They had it,
so
sir.
then I feel very happy. Thank you very much.
Thank you, sir.
Thank
Have a
you.
good day, sir.
Okay, same to you.
Thank you, students, and thank you, participants, and professors and learners. And if you have still not filled up this feedback form, it's still live in the chat box. So before leaving the session, don't miss to fill up the registration form or the feedback form, so which will justify your attendance. So thank you so much. Thank you, everyone. Have a nice day. Thank you, Bhubanesh.